Tactile information is also interesting for pain. How many of you say pain is interesting? Anyone who says pain is interesting? I love pain. No one? All of you say that pain is very painful. Pain is painful. But pain is very important for our survival. If we do not have pain sensation, then it will be very difficult to live. But interestingly, the entire body has pain receptors. But if I open your brain and start operating it, you will not feel the pain. Because the brain itself does not have pain receptors. So it will be painless. You can go to anyone and say that, open my brain and see, I will not feel pain. It's fine. You will not feel pain. But there was a case where this girl, she never felt pain. And see, it's life-threatening, because if you do not feel pain, it can be very dangerous. It's a small video, I can show this one.
There are many rare diseases in the world. A 12-year-old girl, Ashlyn Blocker, suffers from an exceptionally bizarre genetic disorder and has a congenital insensitivity to pain. Simply put, she can feel absolutely no pain whatsoever. The disorder is very dangerous because the inability to feel pain means that sufferers may not recognize a potentially deadly problem, as the warning signs cannot be felt. As an infant, Ashlyn never cried. Then, at 8 months, her parent took her to the doctor for an irritated eye. Medical staff noticed that she had a corneal abrasion, which should have been very painful. That visit led to multiple tests, and almost 2 years later they received a diagnosis. To this day, Ashlyn will still sometimes stick her hand in a pot of boiling water to fish out a dropped utensil, forgetting that it will cause her skin to burn even though she won't feel it. Serving as an inspiration, Ashlyn and her family have started Camp Painless But Hopeful, a camp designated to raise awareness and help families living with congenital insensitivity to pain.
So imagine that you put your hand in boiling water and you don't feel anything because there is no pain sensation. What will happen? It's dangerous, because you will just, your hand will go. And suppose just a normal case, you go and bump into and you keep trying, because every time you bump you feel the sensation, but then you don't feel it. And you can't move into the world. So touch might be very important and interesting part of our survival. If we do not have touch, then I don't know what will happen. Again, a biology class. Taste system, I'll skip this part, also you can just go through. We have buds, and which gives the sensation, but I am not into this, biology part. Human olfactory system, olfactory is smell. I have a 2-minute video. Just see the video and then we'll move on.
That's smart. So what is the next sense you want to learn about today? Of course, the sense of taste. Your favorite, isn't it? Humans have a very developed sense of taste. We love to eat varied flavors. We are also the only living things that artificially flavor and cook our food to enhance its taste, aren't we? We can detect these flavors thanks to the taste buds on our tongues. Let's take a closer look at your tongue. Can you guess how many taste buds we have on our tongues? Not even close. We have around 100,000 taste buds located on the front and back of our tongue. Okay, now guess this. How many tastes can your tongue detect? Wrong again. Actually, there are only a few basic tastes that can be detected by our buds, mainly being salty, sweet, bitter, sour, and umami. Confused by umami? It means meaty or savory, as in fish or ripe tomatoes. When you eat something, the saliva in your mouth breaks down the food, and the taste buds sense the basic tastes. This message is sent to the brain, which then detects the right flavor. Hold on there. Did you know that your sense of taste is incomplete without your sense of smell? Well, smell and taste go hand in hand. Our sense of smell is mainly provided by our nose. Your nose smells the molecules in the air, and sends these messages to your brain. The brain can then tell you what you are smelling. As humans, our sense of smell is very poor. Many animals are blessed with a much keener sense of smell than us. When you eat something, the smell of the food plays a big role in detecting the right flavor of the food. In fact, without smelling, your apple and a pear would taste exactly the same.
So, but it's again a very simple idea, but the point is, I remember we did one experiment when I was doing my PhD. So you mix the taste. It's also not only the taste but smell, but you can also bring in some kind of color. So imagine coffee taste in orange color, or an orange taste in say black color. You will have very huge difficulty to get the taste because your color sense says that orange should look orange. But it doesn't taste, it tastes like orange but it's not orange color. So there is a confusion, and the point of this whole thing is that all senses, they somehow integrate, and that's where the bigger picture comes into our brain. And we still have no clue, we do not know much about how this integration, we know how the integration takes place, but we do not know how this is represented at conscious level. How do we actually get the conscious experience of something? Is there a specific part of the brain? We do not know. Is it a combination of all of it that comes into play? And that's where the entire discussion of mind and body came into play, because people said that brain is doing all kinds of processing, but your conscious experience is different. It should not be. So people who believe that it's just brain that is represented, they are materialists. And people who believe that no, processing is one thing, but then there is something called mind or soul, which is different from matter, that is dualist view. We have seen the sense of balance, which is vestibular system. If you do not have this vestibular system, you will not be able to stand or sit. Every time you will keep falling. I have a video, but I'll skip it. Then comes the eyes. Nobody, I have seen that when you are in love, you say that your eyes are beautiful. But we never say that your tongues are beautiful. Or you say that your nose are beautiful or ears are beautiful. Try doing it and see what happens. I have never tried. But why, I don't know. It's just one passing thought. Again, for vision also we have a spectrum. Like auditory sense, we also have spectrum, and we can see only that part of the world. We do not see anything which is beyond that spectrum. And visible is this: red, orange, green, yellow, blue, indigo, violet. And anything below red is infrared. It goes down to radio waves also. If you are interested in space and universe, you will see that people now talk a lot about black holes and other kinds of universe matter. How do they know? They are not looking through these visible lights. If you just take the telescope and start seeing, you will not be able to see much. But then they go to radio waves also. Sometimes they go X-rays and gamma waves also. And something which we cannot see, but it's again a different kind of representation which allows us to make sense of the object. So it's not always the visible light which makes sense of the world. It also is the beyond our human capacity that makes sense of the world. Candela's intensity that we have, if you have more light, then it can damage your eyes also. white paper in moonlight, white paper in starlight, weakest visible light is 10 to the power minus 6. Okay, this is the last such image. If you get a chance to download this presentation, just look at it. Here I'll just want to talk about two things, rods and cones. And they are important because they take light and color. We have 10 more minutes. Now something interesting. Last class I had discussed about, you remember the light, one flash here and the other flash there, and you see the movement. And we asked that why this happens. Did anyone find out why that happens? Okay? You don't have to, because next class you knew that I'll come and talk about it. So there is a person called Eagle Man, and if you get a chance, just search on YouTube, brain or cognition Eagle Man. And there is a small documentary of 45 minutes. It's a very interesting documentary about how brain functions by Eagle Man. I guess it's a BBC documentary, nice one. And you can see that how actually the entire class, they have done it very well because video. But this man actually did a very interesting experiment, and it's called flash lag effect, and the experiment was flash lag experiment. So you see this ring, and this ring will move around this red square, okay? And in one frame, there will be one flash, and flash is always inside this ring, inside the ring. But when you run this video, what you actually see is different. I repeat it. What you are actually seeing is this. Not inside the ring, but outside the ring. Okay? See it again. Right? But actually it is happening inside the ring. If you just look at the video and try to look at the frames, you'll see that flash is happening inside the ring. Can you think why it is happening? A very commonsensical answer. Actually, anyone? There were two answers that were provided. And this is a long case. Actually, for long people knew that this happens. Two answers. One answer was that ring processing and flash processing, they are two different, they happen at two different speeds in the brain. So by the time ring is processed, the flash has not been processed yet. So that's why you see that ring moving and flash happens. So you don't see it inside it, but you see little below. That was one explanation. The second explanation was called prediction. Prediction. So our brain is smart, although it's lazy, but it's smart. What it does is that it knows that by the time you process the flash inside the ring must have moved, because we know that it's moving. So since it's moving, by the time, even if it is say 80 milliseconds or 100 milliseconds time it takes to process the flash, the ring has moved. So what it does is that it puts it behind. So ring is moved further and the flash happens there. So it's called prediction. So the idea basically is that the brain takes information of the speed, direction of the ring, and then based on that it decides where to place the flash. So brain does a lot of calculations, right? It's called prediction. And that's where our previous question also came into picture. One flash here, the another flash here, and the difference, if it is less than 80 milliseconds, you see a light moving. So it's the same problem. So what this man did, he changed the direction or changed the context. So in this case, see the video. You know the direction of the ring, so the brain can calculate. But suppose there is no previous motion, the ring starts from the point, then how the brain will even know that the ring is moving or not? Because the prediction theory says that brain is taking your previous information. So see here, the ring is starting and it has no background information, but still you see the same effect. So Eagleman actually did 2-3 more experiments, and his claim was that he did not call it prediction, but he called it post-diction, which means, and he actually did a lot of other experiments also. He changed the speed and direction of all these things, and finally he came to a conclusion that around 80 milliseconds is the time required for the brain to project the information to you. So that means what we see now has already happened 80 milliseconds back. So brain takes 80 milliseconds time to give you the information. It does a lot of waiting. It tries to make sense of the world, because it's just not that it happens and you see it. A philosophical implication of this finding is that we all live in where? Past. We do not live in present. What you are seeing is 80 milliseconds, it has already happened. And your brain does not allow you to even look at it the way it has happened. So it's 80 milliseconds time, and that's why the light that we saw, the previous class, saw a motion of light because the brain was taking 80 milliseconds time. So it did not tell you first flash until the second flash happened. So you did not see the first flash until the second happened. So only when the second happened, the first was shown to you, and then you saw the movement. Little complicated, but again it shows that vision system is very messy or interesting. There are few more slides and then we'll go for break. Gestalt theory, you know. So far we have seen, what we have seen is, one, that we have data coming in from outside the world, and then all coming in the form of electric pulses, but then they are going to different destinations. Auditory information goes to auditory cortex, visual goes to visual cortex, and then they are processed. But it's not the raw processing. You put, it's like, anyone who cooks here, all of you cook? You put a lot of stuff, but the taste is, what taste is it? So imagine pasta or something, I don't know, Indian curry, if you have tried. What taste is it? Spice? But it has, at least 20-30 spices. Which spice? So if you ask me that, since I also know how to make curry, if you want my expertise, call me for party. I'll cook. And but the point is that you put lots of spices, but the overall taste is not corresponding to one. It's a complete picture. Gestalt theory, what it suggests is that the whole is greater or different from the sum of its parts. So that means you put 1, 2, 3, 4, 5, 6, and if you add them, the number, it's not arithmetic kind of stuff. One simple example I'll give you. In philosophy this is discussed. It's a question of category difference. Where is University of Cagliari? Where is University of Cagliari? Show me. Can you show me University of Cagliari? If you can show me, I'll take you to Cafe Roma. Again, once somebody had a coffee due, so remind me. But can you show me University of Cagliari anywhere? Why? Where is it? Here? But this is the
same way.
Here it's, but then is this University of Cagliari? I click a picture here and say that, oh, see, this is University of Cagliari.
In a way.
In a way, okay. But what is the other way?
Geographic.
Okay, so in map you might show that, okay, this is the University of Cagliari. Map, okay. But that's the buildings of University of Cagliari. That's not University of Cagliari. Building or departments of Cagliari. Where is the University of Cagliari? Anyone? Concept of university, but can you show it? So see, you see the problem? The problem is that you can show buildings, you can show people, you can show spaces and other things, but you cannot show the concept of University of Cagliari. It's a different category altogether. And that in some way, if you add students, buildings, computers, chairs, everything together, University of Cagliari is still different from all of this together. It's a different category. And that's where the vision, or not only in vision, but Gestalt principle is applied on perception. There are 5 principles to it. It was developed by Wolfgang Kohler and Maximilian Waldmeier. So there are 5 principles. You know, remember Kant, Immanuel Kant? You have read about him. So he talks a lot about, you know, categories and senses. But okay, keep it aside. 5 different principles of Gestalt. We tend to put things or perceive things as one unit if they are close enough, which is called the principle of proximity. It's just dots, but you will see two together. So it's a unit that you combine. You consider it as one. This would be interesting for people who do designing stuff. For designers, talk a lot about Gestalt principles. How to group things together. Grouping is one interesting part. Again, these 6 lines are not 6 lines, but they are 3 lines of 2 units. Because they are close. There also you are putting things together because they are together. Close. Similarity is another principle. You combine or group things if they are similar. So here you see different lines of different colors or squares. Symmetry is one thing that proximity will say that these 2 things should be considered as one unit. But we do not consider these 2 as one unit, but this as a bracket. It's because of symmetry. Continuity, A, B and C, D, they are 2 lines, right? But you don't say they are 4 different lines. The reason is that your brain says there must be a continuity. So that's why D and C, even if they intersect somewhere O, suppose A and B, you don't say 4 different lines. You say that it's a continuity. So you combine or group things based on continuity also. The other and the interesting one is closure, that our brain sees things as closed things. So it imagines, it predicts what would be the closure look like. So in this case, there is no circle, but you see a circle. It might look like an illusion, but this is how your brain does. Your brain organizes objects. In this case, it's, you know that there is something missing, but you see that it's a circle on which something has come, or, you know, not the cut part. You consider it as a full circle. Again, there is a triangle here, whereas there is no triangle because it's a notion of closure which is working at the background. In that case also, you create what do you call an object, some kind of thing. Both of them are same. What is it, O or C? C? O? It's both. Again, the context which decides that whether you will consider it as O or C. A, B, C, 12, 13, 14. So again, the grouping is not again in isolation. There are 5 principles, but context also plays an important role in organizing them, whether you will see this as 13 or you will see this as B. This you have seen, a vase or 2 faces. This is called background and foreground. Which one do you consider foreground or background? And in this entire thing comes a very important processing called top-down and bottom-up processing. Bottom-up processing is that whichever is coming in, you just see it like that. Top-down is that your concept puts things there. So in triangle case, we have seen that, triangle. It's a top-down processing. You know that it should combine and make a triangle. This one is a rabbit or duck. Duck? Both. Again, it matters that how you want to see it. It's called top-down processing, that your brain is asking you to see a duck or a rabbit. It's an old woman or young woman. Can you see young also in this? An old woman also? Both? Again, so it's bottom. So the data which is coming in is same for both, but it's the concept which is allowing you to see both.